Good day everyone, my name is Fahimah. Today I will be introducing our topic, the nuclear fusion-fission hybrid reactor. Simply put, this reactor is a combination of two nuclear technologies. It uses fusion, which is how the sun makes energy to power, and helper control fusion, which is how normal nuclear plants work. By combining both, we get a brand new, super smart way to generate electricity. Why this is a big deal for modern physics? First, it destroys nuclear waste. It actually takes dangerous waste from all nuclear plants and burns it as fuel, so less pollution. Second, it is 100% safe. Unlike normal reactors, this hybrid system cannot melt down. If there is an emergency, we just turn off the switch and it safely. To prepare this topic, our group used a few simple methods. We did online research to find reliable science articles, looked through physics textbook for the facts, and make a group discussion to make sure we could explain it easily to all of you. Building this is hard. The biggest challenge is the extreme heat. It is hotter than sun. No material on Earth can touch that without melting. Scientists use powerful magnetic field to float the hot energy in mid-air inside a donut-shaped machine called tokamak, so it never touches the walls. So that is all from me. Now I will pass it to my teammate.
For this slide, I will be presenting about the concept of a fusion-fission hybrid reactor and its application in a modern nuclear energy. A fusion hybrid reactor is an advanced nuclear system that combines two different nuclear processes, which is fusion and fission. In this system, fusion reaction generate high energy neutrons. These neutrons are then used to initiate fission reaction in fuels such as uranium-235 or thorium-232. Unlike pure fission reactor, the fusion process in a hybrid reactor is not primary source of electricity. Instead, it serves an efficient neutron source that drives the fission process. The fission reaction releases a large amount of thermal energy, additional neutron, and fission products. The heat generated can be converted into electricity through conventional power generation system. This hybrid approach aims to combine the advantage both of the technology and by increasing fuel efficiency, reducing nuclear waste, and improving overall energy production. Now, let's look for an example of a nuclear fission involving uranium-235. The process begins when a neutron collides with a uranium-235 nucleus. After absorbing the neutron, the nucleus becomes unstable because it gains excess energy. As a result, the unstable nucleus split into two smaller nuclei, commonly barium and krypton. During this splitting process, a significant amount of energy is released in the form of heat. Additional neutrons and gamma radiation are also emitted. This released neutron can strike other uranium atom, creating a chain reaction. This chain reaction is a fundamental principle behind nuclear reactor and nuclear power generation. The energy produced from each fission event is based on instant mass energy equivalence principle, E equal to mc square, where a small amount of mass is converted into a large amount of energy. This makes nuclear fission one of the most energy dense source of power availability. So, let's move on to the benefits of nuclear technology. Basically, nuclear technology is used in many areas that help improve of our daily life. For example, the most common use in nuclear technology is electricity generation. Nuclear power plant produce a large amount of electricity and help meet energy demand while reducing carbon emission. Next, nuclear technology is also used in naval transportation. For instance, submarines and aircraft carriers use nuclear reactor because they can operate for a long period of time without frequent refueling. Furthermore, nuclear technology plays an important role in medical field. For example, radioisotopes are used in a PET scan to help doctors diagnose disease, and radiation therapy is widely used to treat cancer patients. Besides that, nuclear technology is also valuable in research and industry. Scientists use nuclear facility to study new material and conduct experiment, while industry use radiation for sterilization, quality control, and material testing. Now, let's see some recent advancement in nuclear technology. First of all, one major improvement is better fuel efficiency. In other words, modern reactor can generate more energy while using fuel more effectively. Another advancement is the reduction of radioactive waste. For example, some advanced reactor designs are able to recycle or refuse spent fuel, which help reduce waste. Moreover, safety systems have improved significantly. For instance, many next generation reactors include passive safety feature that automatically cool the reactor during an emergency without a human. In addition, technological innovation have increased energy output while maintaining high safety standards. As a result, nuclear power plants are becoming more reliable and efficient.
For waste management benefit, first of all, proper waste management significantly reduces pollution and helps protect our environment for future generations. Secondly, it is economically beneficial because recycling and efficient waste systems save money and create new job opportunities. Finally, by keeping our surroundings clean and free from hazardous waste, it directly improves public health. Moving on to the recent advancement in this field, we can see major projects like China's Tsinghua hybrid reactor project, as well as the development of small modular and fast reactors. However, this technology comes with significant challenges. First, they involve extremely high costs, and second, they suffer from immense technical complexity. Additionally, there are strict safety and regulatory concerns to address alongside a lot of commercialization uncertainty regarding whether they can be widely adopted. Now, let's explore the potential career path in this field. As shown on this slide, graduates or professionals can pursue career as nuclear engineers, reactor physics, radiation safety officers, or material scientists. Each of these roles play a vital part in advancing and securing nuclear technology. To truly succeed and excel in today's competitive industries, relying solely on basic qualification is no longer enough. We need to actively equip ourselves with these four core skills. First and foremost is having strong mathematics skills. Mathematics is the foundation of logical thinking and analytical reasoning. In the workplace, we need math not just to solve formulas, but to analyze complex data sets, interpret statistics, and make data-driven decisions. A strong grasp of mathematics helps us solve problems more efficiently and accurately. Moving on to the second skill, which is physical knowledge. Understanding physics allows us to comprehend how things work in the physical world, whether it's involved electronics, mechanical system, or advanced fields like nuclear energy. Physics provides us with the core concept required to innovate, troubleshoot complex equipment, and understand technical system deeply. The third skill is communication. Now, how brilliant you are in math or physics, it won't matter. If you cannot convey your idea effectively, career excellence requires the ability to translate complex technical concepts into simple, understandable terms for client, team member, and stakeholders. Good communication fosters teamwork and helps us pitch our ideas successfully. Last but not least is engineering design skill. This is where our technical knowledge meets creativity. It involves us the ability to use modern software and tools to design, layout, and build prototypes or simulate engineering system. Having the skills means we are ready to adapt to the industry demands and contribute directly for practical and real-world solutions.
For our next point, let's discuss the significance of continuous self-development within this field. As we know, technology in nuclear physics is constantly improving. Because of this, it is absolutely essential for scientists and engineers to commit the continuous learning. By keeping ourselves updated with new reactor system and safety method, we ensure that our knowledge remains relevant and effective. Furthermore, learning new software and modern technology directly increase work efficiency. This continuous growth doesn't just keep us updated, it also helps individuals become more innovative and adaptable in their future careers. Ultimately, self-development improves vital soft and hard skills, including problem solving, communication, and technical skills. Alright, so now I want to talk about the challenges and also our strategy. First, we have safety risks. To mitigate this, our strategy must involve following strict safety procedure, utilizing advanced cooling and monitoring system, and conducting regular maintenance and inspections. Second, there is the challenge of high cost. We can address this by implementing hybrid system to increase energy efficiency, while maintaining strict safety procedures and regular inspection to prevent expensive setback. Third, we face radioactive waste problem. The strategies here rely on developing better waste recycling technology, storing waste safety in secure underground facilities, and continuing intensive research on reducing radioactive materials. To conclude, we can summarize our main takeaway into 3 key points. First, fission hybrid reactors represent an important investment in modern physics and energy technology. They hold massive potential because they can produce large amounts of energy much more efficiently than traditional method. However, we must acknowledge that challenges such as safety, high cost, and waste management still exist. Fortunately, with continuous solutions and technological improvement, we can continue to develop and refine these technologies safely to the future.